there are a few things that I want to achieve during the summer. Apart from getting a job to work, that's one thing which I'm trying to do. But apart from that, I have some projects I want to work on before the next year starts. They're not necessarily like time bound, because like, to be honest, like these courses and these modules I'm doing in university for my computer science course, they're not that like super interesting. Um, I kind of wish that computer science was a bit more computer science than like AI science and whatever. But whatever. So it kind of means that I have like 3 more years of free time, a lot of free time. Granted, I can stand up my grades, of course. But anyway, so a few of these projects, some of them are to kind of list them off, right? There's first of all modding and reverse engineering. That's something I want to get really good at, so I can reverse engineer applications and games, and then mod those games, mod that software, which would be kind of fun. And that also has like overlaps into like cybersecurity as well, besides just game modding, which could obviously be good for career prospects. Not that I want to be like a cyber security, can I say that? Cybersecurity, but just a thought. So that's one thing. And for that, like I was working on my NUCC C++ library. I have videos on that on the channel where I've made that project, and that's in C++. I'm gonna do it in Rust as well. So there's that as well. That which I don't know. For that project in general, to continue it, I kind of need a stronger motivation right now, because like I'm not modding the game right now that uses that engine. So maybe if like there's a new game that will be announced soon-ish, but like it could be announced as late as like September even. So I don't know about that, but we'll see. That the new game would use it. I say new game. It's a remaster of an old game that uses the same engine. So then I can get back on modding that. Because then if I make tools for that, then people would appreciate it, because then they can use that, right? So that's one thing in my mind. Another thing is developing my own programming language. That's a really big project I want to work on. My last few videos have been focused on that, I think, right? Like you can see, I was looking at unifying if and pattern matching, which is something that I think is very promising, but I'll come back to it later when I understand more about type theory and just like other like kind of like just more generally what kind of language I want to make. Like I started making this thing called programming philosophies, and right now obviously like it's very lacking. Although these are links to explanations, but like I want to kind of just like note down what do I actually want from a programming language. What would constitute the perfect, or at least near perfect, programming language? And for that, because I can do like these concepts for like these individual features, but really the best features synergize with the language as a whole and are consistent with the language as a whole. Like with the if statement stuff, right? Not only like the implications of the if stuff that I was talking about in my last video was that instead of having pattern matching, you would rely on an is keyword or an is operator, which can then also be used for equality. So then we no longer have a double equal sign. Instead, we have an is keyword, which can be used both for checking its values, but also checking out structures and types, right? So like you could say is foo is int, then also foo is 5. And maybe this is a mistake. Maybe it shouldn't be that way, but I don't know. And then like there's implications on all sorts. So that's something I also want to get back onto. I'm following RS locks. Well, I'm making RS locks. It's not open here right now. This is someone else's project, which is locks in Rust, following the crafting interpreters book. I'm going to continue that project. Of course, I've pretty much finished it. I just have a bug in the parser that I need to do. Sorry, I've not finished it. I finished the parser is what I'm trying to say, which is the second stage. So I'll get back on that at some point, but likewise with that, I also want to do more research on programming languages in general. Like something I want to get into is type theory, which overlaps with category theory. Like this page here, the co-product is part of category theory, but that also overlaps. I say overlaps. Rather, like type theory is more like a subset of category theory, and that type theory just like specifically focuses on programming, whereas category theory is like the ultimate general theory of types and categories and all that kind of stuff, and sets and all that. So that's something I also want to get into and do more research on. So there's that whole thing. So yeah, programming language design and theory. That's the other thing. For whatever reason, and again, it's really sad. They don't teach us in university. At least to my knowledge, there's no university module in my course where they will teach you like category theory or type theory or like really anything programming language focused. Even though like people really have PhDs in this kind of thing, instead most of the PhDs and doctorates and the research in my university seems to be around AI, and that might actually be it. So that's really unfortunate. And I guess like also like proofs. Like the maths behind computer science, which is like it's alright. Like it's not why I chose computer science. So there's that side of things. Another thing I want to do is by the way, with the reverse engineering stuff as well that I previously mentioned, there's also the pwn.college. It's a course that will teach you reverse engineering straight up, learn to hack, right? So that'll be good to follow. And within that, and the other side of things, again, is web development. There's the Ozone project, maybe you've heard of it, where it will teach you how to do web dev with React, HTML, CSS, JavaScript databases, Ruby, and all that kind of stuff. Something I care less about, to be fair, but I think would be interesting to at least, at least do this Odin project course, whatever, or like at least start it and see where it leads. So that's another thing I've been not putting off doing, because like I'm doing other things in the process in the meantime, but more just like at the back of my mind, thing I want to then go on to do. And I guess that's it, like programming wise. There are other things I want to do, like language learning. I want to revive my YouTube channel and whatnot. But like for programming, I suppose those are the three main pillars. A fourth one could be game. Oh yeah, actually no. A fourth one is also game development. There's a Samurai vs Zombies fan game I want to work on, as well as a mod for the game. Although the mod is not a traditional mod because I actually have a decomp, so it's more like modding the source code, which is pretty cool. Which is more game development than it is like directly modding. So that's another thing I want to do, and that's something I've not really come back to in like a few months, if not quite. Well, yeah, a few months. I think like the last time I worked on that was like January, and it's now almost July, so time flies. So yeah, I kind of wanted to start by talking about that because there's quite a lot of things that I want to do, and it's hard to choose like which ones I want to focus on. Not to mention like I said before, I still had to get a job and all that, which again I'm applying for. But if I do get one, it will take time away from me even more. And then once the uni starts in September, which is in, to be fair, like 2 months and a bit, so I do have quite a bit of time still. But that will also, of course, take up a lot of time. So yeah, it's not easy. It's not simple. But I'll see. I mean, the question is, what do I prioritize right now, right? Like, first of all, with my YouTube channel, I want to revive it, but I really don't have the best tools right now. I don't have a good laptop or computer, just in general, to edit videos well, or at least like edit videos in a non-frustrating way, and like without limitations. So I probably will put off reviving my YouTube channel, like my main channel. This is my second channel, that I'm uploading this video on. But that kind of stuff will start happening when I can fund myself a new computer. So that will, of course, rely on me on my job and all that. So that's put off. Language learning is cool, but honestly, its usefulness is not super great. If I could find the usefulness is great, but like because like obviously learning a language is incredibly beneficial. What I mean is the time to usefulness ratio right now is not looking like it's worth it. Like the amount of time you have to sink into learning a language is astronomical. I mean, it's not astronomical, but like it's not easy, and it requires lots of practice, frequent practice, and it's something that I just don't really have time to do right now. Not to mention my motivations are really weak right now because I literally have no one to talk to in other languages. Like even like for my best case right now is I have a friend who speaks Urdu, but like he speaks English fluently, His English might even at this point be better than his Urdu because he moved to the UK when he was like 7. So like, or like at least in year 7 maybe. So it's like what, like if I learned that language, then I would just be learning it to speak with him, but like I wouldn't use it anywhere else. So that's kind of sucks. For like Japanese, that'd be great to learn, but there's no one here. I have not met a single Japanese person, by the way, while here in the UK so far in university. And like I have all these things I could read with Japanese, which is great, but I'm not reading anything anyway. Like the things I'm reading right now are in English, and they're not manga or anything. Like I'm reading like stuff like this, you know, like stuff on like programming theory, like this. Sorry, which obviously isn't in Japanese and would probably be better explained in English anyway. So that is just not really strong motivation. But obviously I'd love to be bilingual. Who wouldn't? So we'll see, or well, really multilingual. So we'll see what happens there. So that's also off the table right now. For web dev, I am creating a website, but it's just a portfolio, so nothing too special there. Yeah, but I don't know. Actually, have I even made a video about that? I haven't. Yeah, so for those who don't know, I've been developing a website for those who don't know, which is everyone, which is, I've developed a website in Rust using Leptos, which is my portfolio. It will go on kojo.me, which is currently reserved for my blog, but I want to move that domain to my personal website and have my blog be like a sub page on that. Whatever. So that's something. But like it's mostly a static site though, so like it's not really that crazy. So like that kind of web dev isn't that web devy. You know, like I'm not like using Ruby or anything, and I'm using Rust on JavaScript. So there, whatever. So that I'll just continue with, but I don't know. Going deeper into web dev though, I'll probably save that for when uni starts, because I am doing a computer networks module, which will teach me how the internet works, of course, and also some like cybersecurity things. And then, you know, with the internet, you of course have websites, so maybe I can do something with that course information knowledge and do something there. I don't know, we'll see. Plus I'm also doing a scripting module which will teach me JavaScript. Not that I mean I know some JavaScript, but like really it's not that much, especially like more modern JavaScript. So, and then the two other things are modding. No, three other things are game development. Game development I'm also thinking of just putting off because of how not as important it is to others. Like obviously I'd love to continue this fan game and stuff, but like the actual importance of it is not huge. It's mostly just for fun, and I can't afford to do things for fun, it seems, right now. So that's something. And the two other things are reverse engineering and programming language. Reverse engineering and modding are things I really want to focus on because that will give me the skills I need to become cracked at absolutely everything. So that's really cool, but I haven't focused on it in quite a while. So I'll get back on it somehow at some point. The other thing is making a programming language, right? And that one's really good as well, and probably the one that's most worth focusing on, because I will learn type theory, which is very useful, and that could also help me with category theory, which is just generally a really good thing to know about. Like category theory is kind of the mathematical theory of everything, right? The theory of grouping and all this kind of thing. Of like categorizing, right? And if humans, you know, we definitely do categorize and like abstractions and all that kind of thing. So that's really interesting and definitely really worth learning and focusing on. So also I need to finish the C++ documentary. I just realized. I'll get on that at some point. Although to be fair, it's probably not as high priority. It's more just because it's awesome. So I'll probably continue focusing on with for now the programming language stuff, and for reverse engineering and that modding, I'll get back on that. I think what I'll say is I'll get back on reverse engineering and modding when Eyes of Heaven R, the JoJo game that has been leaked, is officially announced, because then we'll have confirmation. Hopefully a release date so that we can work towards, and it will generate hype back in the gaming scene for JoJo games. And because that game, Eyes of Heaven R, would use the same engine as All-Star Battle R, which is the game that I've been modding for the past 4 years now, I think it's been. So the tools that I will make that we've been making for Ultra Battle R would also be relevant for Eyes of Heaven R. So that would be the motivation that gets me back into modding, because ASPR is a cool game, but like I mean I can't even play it on Linux for starters without like some, I don't know, what's it called, translation layer like Proton, and it's a cool game, but like it's a fighting game, and I like fighting games, but it's not a game that like I'm gonna play like super frequently, because you know fighting games are also a huge time sink. If we had like a fighting game society here in Liverpool University, I would love to join it, but we don't. And I could start one, but like I'm not that fussed about it, because again, massive time sink to focus on those things, and I think they're better things to do. So there you go then. So when As I Have an R releases, I will gets announced. I will talk more about this further. But for now, I'm gonna focus on programming language stuff and really just reading. Just in general, even outside of all these things I've talked about, I just want to read more and consume more information. And I over this summer really brain max myself, you know, thought max and information max, so I can become mega brained. Like I have all these books right now in my room that I simply just haven't really stopped to read. I also picked out like a few library books, but over the year, but I really didn't read any of them. Like I got Mein Kampf, for instance, because I thought it'd be interesting to like read about, I don't know, Hitler, obviously, but I literally didn't even start reading it, and I've returned it because it was due already. And there's like this book on programming languages stuff, but it was kind of boring, to be fair. But like I should have started reading those more books. And like I like right now my camera is literally lying on top of a pile of books, which I haven't started reading either, even though I really should, because I think it could be interesting. Right now my laptop is literally on top of the Bible, the Holy Bible, just so I have some like ventilation. Which is another book that I've been meaning to read, because I want to like, you know, get into philosophy and religion and that kind of stuff, but I just haven't taken the time. And like it's not because like I'm lazy and I'm not doing anything. Like it's because I'm busy with other things. So there's so many things I want to do, but I just don't have the time to. But regardless, even if I'm not reading those things, I at least want to be reading something. So crafting interpreters I'm not going to count, because that's more of a guide than anything. But like this category theory has a lot of things to read up on. I think I saved a few things. I don't know why Indeed is bookmarked. That should be somewhere else. Like there's books on type theory, for instance, that I want to read. And I have all these articles here as well from like on programming stuff. So I want to read those. Anyway, that takes me to the topic of this video. This is the website of someone called Sock, which is kind of confusing. I mean, it's soc.me. If you want to have a look, I'll link it in the description as well. But they don't seem to have like a proper like about me page, so I couldn't really tell you much about this person. But they have a website where they have like a lot of links, and I think most of them are like articles that they made and they wrote. And I know this person from the Programming Language Design Discord server. They're listed right here, right now. This is Sock. And we were talking about the if statement, pattern matching, unification stuff. And then they sent me their stuff, like their thoughts on it and their take, and it ended up being pretty much like exactly what I was also thinking, which is really cool. So naturally, I want to have a look at their other stuff too. So I'm gonna start here. This video isn't like strongly structured on any particular text. I'm just gonna go and look at these, and then if anything such my interest, I will start reading it, and we'll see what happens then. For this stuff, category theory, I'm gonna close this page, but like, yeah, I'm gonna close this page because I'll come back to it later, but. What I can tell you right now is that a co-product in category theory is like a sum type in programming, an enum, right? A tagged union. and it's like a coproduct. A coproduct is another name for that. Whereas the opposite would be a product, right? The product type and the sum type. Whereas a product type is like a struct or a tuple. And you can see here as well that another name for the coproduct is the categorical sum. So very cool. There's like this diagram that I don't really understand, but I will come back to it later once I have read up on the basics of type theory. So let me just turn on my light and we'll have a look at this. I also... Oh yeah, I hope the... I'm worried that my recordings probably have like a lot of background noise because my fan, but yeah, it's hot. Yeah, by the way, like it is hot. I mean, here it's not too bad. It's like 31 degrees, which I'm fairly accustomed to, having lived in Malaysia and like Qatar and Vietnam, but like it's still like in France. I've heard like it's reaching literally above 40 degrees, which is hotter than it is in like most Asian countries. Like that is insane. I mean, if I check the temperature now in Qatar, temperature Doha. Like in Doha right now in Qatar, it's it's nighttime. Is it nighttime? It's evening. So like it's right now it's 37 degrees, and it says here it was reaching 41, 42, 41. Which is crazy, you know. I mean, like, but like, it's a desert, right? So it's like it's not too surprising for summer. Look at France, bro. 40 degrees today, and it was cloudy. Like the heat wave is insane. Thankfully, it looks like it's gonna go down, so that's good. But yeah, man, global warming is no joke. So one more thing to mention. I said I want to read more. I also wanted to take notes while I'm reading. I that's kind of important to mention as well. Let me close these. This is the thingy. I started this post on... Oh yeah, that's right. Also side note, I started this thing on like my programming language that I want to make. I don't have a name for it. Maybe called like Kojo, except I can't because someone else called the language Kojo for some reason, even though they're Indian. I don't know what the hell the connection there is to the name Kojo, but yeah. Anyway, but I shouldn't name it after myself anyway. Should name it after like its philosophy. So I've already floated with the idea of a language, particularly in unifying variable and function declaration syntax. So like you can see here that like an x is declared, like a function is declared, a variable, sorry. Just that like the type is a type to type, whereas this is just a thing. And then you have lambdas, and then some like ideas for how it could look, like import standard IO would look like that. I'll probably make it even different, like have colon instead, like a single colon. Or maybe not, because like a namespace should be different than a class. Although, should they be different from a class? Maybe they should be unified as well. I don't know. And then you have like quick start instead of main, because like quick start is like the quick start function. But then if you want to have like function arguments, you would... I don't know. I mean, this is like very quickly made right here. I will elaborate on this as I continue learning more about programming language theory and design and all that kind of thing. And also implementation is important too. Yeah, you got like templates where t is numerical, that is using traits, and t is not equal to 0. And then you have your definition here. So it looks functional, but the language is imperative. Main with the args, if you want to have args like that. Which I think args makes sense. Like some languages opt to instead pass you the args via functions in the standard library. But this way, it's like main is like when someone calls your program, they're passing arguments to it. It just kind of feels more intuitive. But you know, it's up to you, of course. A discard keyword, I guess, instead of let's underscored equals. But honestly, I think that's probably better anyway. Just do underscored like that. But that's something to also think about. And then my priorities, it should be fast, so not garbage collected. It should be like C++ and Rust and C on that level. It should be readable, highly readable. It should be modular and reusable. That doesn't really make sense, but like more like the priority is modularity. So you can write code that is modular and reusable. So like if you write a function in one library, you should be able to use it in another library without having to like rewrite the same code. Scalable, so like unlike say Python, it would scale more like something like Java, where the bigger it gets, you can still maintain a mental model of how the system works. Because say what you will about Java, like it is pretty good in that regard, even though the way it goes about it is not necessarily the best. Package management, yeah, very important. Intuitive and consistent. So like with the if statement stuff, right, and pattern matching, if you combine those into one, then rather than having two separate features that feel disconnected, you make them feel intuitive and consistent with each other, or like you make the language feel more intuitive and consistent because it doesn't have like two different ways to do the same thing, and easy to debug. So those are also the thoughts I have right now. These are the things I care about. I guess some things I don't care about are like yeah, I don't know. I mean, like these, like surely these are things that all languages want to implement, right? What I've done is just like I've taken everything that you could possibly want to prioritize and said I want to prioritize all of them. So really, like this is the everything language that aims to succeed in every single regard. So we'll see how that works. Anyway, I don't know why I still have this open. Sets as programming types is interesting. Would be great to come back to this after reading up on type theory, of course, because sets are a division, you could say, of category theory. Set theory is that, and type theory is another division. So there's definitely overlap that could happen there. I was thinking of some like function call syntax. And 3 and 5 could be interesting. Say D's for that. I need to get back to these notes. I mean, I don't need to, but like it'd be good to consolidate my notes that I learned from my previous year in university. All of these notes are from university. I just haven't like necessarily turned all of them into notes yet. Like Zettels, atomic notes. And my inbox is also quite like full of stuff that I need to also turn into Zettels. Let me get an image of this real quick. That's annoying. Right. Okay. So let's begin. So let me zoom in as well. I don't know what this stuff is about. The directories project. Standard directories for software developers. Applications should follow the operating system's rules regarding the location of configuration, cache files, and other application data. Right, because like yeah, it's quite different on like Linux to like Windows. What are these images? Also, what's Redux? Redux OS. This one isn't Linux. Which is in Rust. Interesting. I wonder how these differ from Linux, like in the backend. Microkernel. Minimal abstractions in kernel space. So they're not monolithic. Interesting. Okay, so like let's click on Linux. I'm guessing there's more to this that's hidden away somewhere. Sorry, so Linux configurability. Some user configurable environment variables can be used to override default locations. For like configs, okay, Windows, none. The known folder API defines intended locations. Mac OS, none. Redux, some. Like Linux. Okay. Linux is a penguin. Windows is a like a prison cell window, which is hilarious. Mac OS. I'm trying to understand what all these bird cages are for. Is this like the illusion of freedom? Because like they're outside, but they're in the air, but they're caged. But I have to know. And then Redux, I don't know what Redux is about, but I'm guessing because it's in Rust, it's like a cogwheel. So this libraries, what's that about? Okay, I don't know what that's about. I got these links here. Okay, so then languages. Yes, like this website. I guess it is a website, but I hesitate to call it that because it's very lacking in like information. There's an invisible type like bar here. Talks. Yeah, I don't know. I really don't know. This seems more like an archive than anything. Like someone's, socks, kind of like link page. So like they can conveniently find links to things that they have. Like a bookmark page almost, but it's also publicly accessible, but like there's no guide on how to navigate it. So it's just interesting. Languages. So design principles. Let's start here. So we'll go in order until we get bored, I guess. So I'm going to assume that these are Sock's thoughts on programming language design. This one's called my thoughts on OCaml, but like, these obviously make sense. These ones are more confusing, like just design principles. Like I'm guessing it's Sock's design principles. Easy wins. Okay, simplicity matters. Mistakes were made. Like those, like okay, like I'm guessing these are all like opinion articles, and or like notes, because like this isn't an article, obviously. Like it's more of a list. The core language as well. Oh, it's called the core language. Okay, so yeah, they are making a language themselves called core. I have looked very briefly into this. I've not looked deeply, so that'd be cool to check out as well. Because again, like this person has at least agrees with me on if syntax, so I'm hoping for something quite interesting, because like I've tried other languages like Odin and Gleam and Nim, and they're just not very interesting. But I hope this one is something else. Then equality and identity is interesting. Yeah, okay, cool. These sound very interesting. So design principles. Let's have a look. Last updated 2022. A smaller language, not a bigger one. Now, I don't know what these crosses mean. But let me try to infer this. Like, reading this is like solving like a puzzle, because I genuinely do not understand what is going on. Okay, so I guess these are like principles of language design. So I'm going to take notes on this as I go. I'm going to make use of my extension here that I specifically got for note taking, and then, rather than like making an Obsidian post right now or note. So it's more language, not a bigger one. Namespaces, types, terms, but not packages, fields, methods, and labels. Okay, let me process this. So, oh, that's weird. Why did it zoom out when I zoomed in? So, okay. A good language that is modern and minimal. I guess that's the goals here. Obviously, because it wants to be minimal, it should be a smaller one, not a bigger one. And generally speaking, you should aim for a smaller one, because that means it's easier to maintain and distribute, and also I think compile times would also obviously probably be shorter because of it. For namespaces, have namespaces for types and for terms. Okay, so types would be like user-defined types, like if I have a class foo and I want to access a variable bar, I would do foo : bar in like C++, and then that is a namespace. Terms, I don't understand what that means. Packages is obviously interesting. You can definitely argue for unifying classes with namespaces and modules. Like Java, for instance, I don't know if it has a namespace keyword to define a custom namespace, but if you want to define a namespace, you can just create a class, right? So that's packages, I'm assuming. Fields, I don't know what that means, and methods. I guess like variables and functions, right? I don't know why those would be have namespaces of their own. And then labels are also crossed out. So again, I don't know what this means. Modifiers, keywords, no, but annotations, yes. And links to an article. Okay, so it's saying rather than having keywords, use annotations. Annotations are stuff like deprecated, test, derive. Interesting. Okay. So let me start. Now that I'm starting to like wrap my head around this a little bit more, let me actually start taking some notes. How do I take a note directly? I don't want to highlight. No, I want to take a note. I guess I need to highlight first, and then take a note. This color though. Can I change the default color? What color is good? Honestly, pink might be the option, but that can get confused with my theme. I'm just gonna go with yellow. But this yellow or this yellow? This is so pedantic. I'm gonna go with the default light yellow. Yeah, I apologize for my whatever. Right, so a smaller language is easier to maintain, distribute, and probably compile. Types, terms, no packages, no fields, no methods, no labels. Sorry, so is this saying types should have namespaces and packages shouldn't? Or is this saying that the language should have types and terms, but not packages, fields, methods, and labels? Is that what it's saying? Maybe. Put that as a question. Is it saying that a language should and include packages, fields, etc.? Or that those crossed out items shouldn't have namespaces of their own, or initiate namespaces? That's a question. I do again like have contact with this guy Sock in the Discord, so I could also just ask him or them Does my Claude keep crashing? Okay. Modifiers, keywords. So no keywords, but yes annotations. Interesting. Can read more about that later because it says annotations obsolete modifiers. Nesting, no packages, but yes modules. What differentiates packages and modules, I wonder? What differentiates a package and a module? And then static. I don't know what static would mean in this context. Members, yes fields, yes methods, no properties. Okay, so the language should have fields and methods then. Okay. So yes to fields, like variables. This is, I guess, for like structs, right? Yes to methods and structs. Okay, interesting. But no for properties. And a property would be like a const, right? I haven't used languages with properties much, so obviously this isn't controversial to me, but control flow, if then else, yes. Yes to returns and while loops. But then no to breaks, no to continues, no to loop as a keyword, I guess. No to exceptions, no to throw, and no to catch. Okay, so a language without exceptions. Okay. These I want to highlight just because they're grouped. I'll make them a different color. Let's say green. That's an awful color. Let's say purple. Again, I don't do pink because my theme is pink, so that can be confusing. Why would you exclude break and continue? I guess so that you only use if statements instead. Why exclude these? Would you instead have to use flags instead? Use flags? In fact, how do you break and continue even work under the hood? Thank God these not having formatting is actually awesome. Even work under the hood. Like I assume it just jumps, doesn't it? Like jumps ahead maybe. Constructors, primary, secondary. What is a secondary constructor? If then else, unified condition expressions. Yeah. So by the way, this is the article that I read that introduced me to this website. And you can see it has pattern matching here, right? If person is person Alice, if person is let age, then this is this. Different syntax than what I use, but the idea is very much the same. At least for what it says in this article. I think they have more ideas as well, but that is, I haven't looked into that as deeply. Literals, no octal number like literals, and no class literals. Okay. Octal number literals. I assume this refers to C using 0, 1, 2, 3, 4 for octals rather than 0, 0, 1, 2, 3, 4. Because yeah, that's also a mistake. Class literals is interesting. I don't know why you would exclude that. Because that's like, yeah, it wraps it in a constructor kind of. It's interesting. And then dot dot dot. I don't know what dot 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 refers to, but correctness. Separate types. So this is the second point. The first one was a small language. So this is really focused on like making the language simpler by making it smaller, and that includes removing features that exist in other languages. Octal number literals. I mean, why would you not include octal number literals? And like hexadecimal and like other things like that. Like surely you would include those, right? Where it makes sense to. Correctness, separate types for identity / equality and ordering / comparing. Ordering slash comparing. Separate types. Okay, so correctness would be like type theory. Right. Yeah, so they do have an article about identity versus equality. For those who aren't, I guess, aware, identity is like who am I, and equality is like what am I. If that makes sense. So like if I take the int 5, right, as a variable, the equality would check what am I, which is an integer with the value of 5. Whereas identity would say who am I, which is I am the variable at this address. Yeah, pretty much. And then ordering comparing is interesting. Ordering comparing is... What's comparing? Comparing would be like equality, right? Or identity. Whereas ordering would be like greater than or less than. I don't know what it means by separate types for ordering comparing. But maybe it's to do with like traits and... I don't know. But that's I look forward to reading about that. Fewer special cases, not more. Yep. Yes. I agree. Means less overhead for the programmer and less surprises for the reader. And of course, a smaller language in general. Operators. They actually advocate for removing unary operators. That would be an interesting article to read about. And then fewer binary operators like add and modulo. Yeah, I wonder what a language... Although it is interesting to have a language that lets you define custom binary operators as Haskell does, even if it's just via some 5 mod Ooh, can I escape backticks? 5 mod 3. Oh, I can. Not. Wait. Some 5 mod 3. Okay, I can. Not. The fuck? Whatever, 5 mod 3 syntax. Can I edit this as Markdown? Because this styling is really not working right now. This is why I don't like word processing or like Google Docs. Like I prefer writing just plain Markdown. Yeah, I can't escape it. But like some 5 mod 3 syntax. Interesting. Magic methods on all types. Like get type. Like what? Like decal type. Collection literals. No. Array syntax. No. Interesting. So collection literals would be like, well, like array syntax, where you can use the square brackets to define an array. Interesting that you wouldn't support array syntax. Like lists in general are useful built-in features to have. Be very interesting. How would a language look without special array syntax? Even C++ with standard array still makes use of the built-in C array syntax with stuff like does this work? It does work. Standard array int 3 foo equals 1 2 3. Instance of syntax and east syntax. Is it like, is foo an instance of thing? Yeah. Okay. And no cast syntax. No casting. How does that work? Would you use constructors instead? Like U32 from U60 from foo. Types have consistent casing, uppercase. Yeah, this one makes sense. And I've also kind of things like U32 instead of U32. Basically, if user defined types follow Pascal case. Simplicity, not familiarity. Generics with okay, now I'm very confused. Are these crossed out things updates where they've like initially included things but then removed them? Simplicity, not familiarity. I assume no, right? Because like, why would you include this if it's not that simple? Okay, so simplicity, not familiarity. Member definition syntax differs only by fun, let, or var. Okay. Higher standards, simple to specify, simple to implement, simple to understand. Okay. I wonder how these are chosen at the bottom, by the way. Like, are they statically embedded into the article, or are they dynamically chosen based on your cookies? Okay. So that was obviously very short, but a lot of questions. I want to come back to this later once I've read the other stuff, so maybe I've a bit more context. But the notes will stay anyway. Like if I reload the page, the notes do not go away, so I can return to it later. Right, familiarity. This is the other design principles branch, and looks more like an article, however short. Familiarity is a tiebreaker and not a self-sufficient argument. Cool. Interesting how these are Socks articles, right? No, it's H. Wayne. Who's this person? I am very confused right now. Are these all from the same person? Or is this person just like, or is this, are these just like, again, like listings of socks, notes, and like special links? I'm just gonna ask him like right now, because I'm so confused. off topic. Okay, anyway, familiarity. Why do I think frozen? Bro, my computer is so hot right now. Oh my days. Bro, I need a cooling system. I need like one of those briefcase computers that comes with like a whole like cooling system. I don't care how, like I don't care how loud it is. Just give me a thing. My thing's frozen. I just realized. Sorry, yeah, I just realized. These are the essays. These are the projects. These are the links, and these are more links. Yeah, like it's rows and columns. Oh my god. Okay, that's gonna be way too long to understand. Okay, anyway, things stop freezing. In my past, many languages did not pick up. Sorry, first of all, from the title, familiarity is a tiebreaker, not a self-sufficient argument. Yeah, I agree. That's a really good. Like that's like it's so like strong. You'd think it came from someone's Zettelkasten. So I'm just gonna highlight that as a note that does not require elaboration. In the past, many languages did not pick up easily adoptable language design improvement and opted for familiarity instead, often in a misguided attempt to keep perceived language complexity down. Rust, by the way. Examples include C's broken operator precedence. Sorry, we got footnotes. C also popular but not wrong. Sorry, popular but wrong. I guess rather than reading this in like a strict order, I'll go ahead and also. I mean, should I like link to them? I don't know how long these are though. They're very short. Okay. So the examples include. C's broken operator precedence. C 100-year mistakes. Okay. Spread to many other languages, most of whom have little in common with C. I don't know much about C's broken operator precedence, but I guess you can read the article linked to find out more. C++'s use of this for generics, which was adopted by languages that, unlike C++, had better options available. Rust is one such example. Stop using. Yeah, he has a whole article about this as well, or they again. C#'s designer properties picked up by languages that did not suffer from C#'s legacy of fields and methods. Right. Okay. Pick 2. Okay. The benefits of familiarity. It is easy because I've seen it before, are limited to those who've seen it before, obviously. While the benefits of simplicity is easy because it was designed this way, apply to everyone, regardless of experience, schooling, or development history. Therefore, it's best to treat familiarity as a tiebreaker, to be used sparingly only when the pros and cons of different design options have been fully explored and it has been determined that no design has an edge above the other. But if one design has arguments for it and another design has familiarity on its side, language designers of the future are implored to pick the former, to stop propagating the same language design mistakes further and further into the future. It's very strange that this is even like something that people do intentionally. I missed a footnote. confusing them is easy. I don't know what that means. Have a look later, I guess. The target audience of this footnote probably hasn't made it this far before losing their mind. But to clarify, nobody is planning on making you code in GIMP. All I'm saying is that some language decisions made in the 1970s, with little thought on design, could perhaps benefit from some scrutiny before copying them into new languages verbatim. You can't really see it, but interesting way to spell 1970s. It's IES instead of just an S. Yep. I must wonder, like, this whole article could like easily fit into one of my Zettelkasten notes. Like, yeah, he's just spitting facts. Like, I don't really have any notes to take on this. It's just true. Familiarity should be a tiebreaker and not a thing. I guess I can make a note out of this, but I'll just not like copy it verbatim. Let me write it first before the title. When designing a programming language, trying to what's the word? Appealing to familiarity of syntax, constructs, etc. should not be a priority. The only time that familiarity should really be taken into account is when there are several arbitrary ways that you could do something, that you could have something have something designed as, all of which are equally fine, and thus the only real and that's the only other factor to consider. Well, unless it makes sense to then just pick the path of least resistance. No, but okay, all of which are equally fine in a vacuum, but one of which stands out for already, or well, one of which is advantaged, rather, or advantageous for already being familiar to many programmers. Like that. Yeah. So familiarity is familiarity is a tiebreaker, not a self-sufficient argument. Familiarity in programming language design is secondary to all else. Topics, program design, obviously. Yeah. Okay. Cool. So let's see what this article links to. Examples include, and then see also popular but wrong. So static members are popular but wrong. Why? I actually like static members. No? Same with like functions, right? Like a constructor has to be thingy, whatever, static. Why? What about do constructors not have to be static? Properties. See this. Okay. I don't know much about properties. This for generic, see this. This for arrays, see this. Angled brackets for generics. Oh, same article. Interesting. Is it saying that you should use this for lists instead? Like in maths, you use this for sequences, which would be honestly what I would use as well. Type or tuples, but tuples are evil. Type indent instead of indent type. I don't know why languages still use this. Having if then else in switch case and a ternary operator. Right, yeah. Having all three, right? Having both modifiers and annotations. Hold on. Oh, sorry. Ternary operator. Yeah, no. Having both modifiers and annotations. Async / await. Really? Why? I don't know anything about async await. I haven't really done concurrency in C# unless I use it for loading like assets, I guess. Separate namespaces from methods and fields. Separate namespaces from methods and fields. I don't know what that means. What does this mean? In what languages is this a thing? Like OCaml maybe? OCaml? Method of loading. I mean, method of loading is popular for other reasons than just there are genuine benefits to method overloading. Such that the debate isn't as clear as the other things on this list. Namespace declarations doubling as imports. Like in Rust, use this namespace maybe? I don't know. Special syntax for casting. Special syntax for casting. Again, what? Like C's? Why is that a problem? I assume because there's an alternative, right? I assume because there is an a better alternative. Using cast syntax for things that are not casts. Fair enough. Requiring this for methods without parameters. Again, like number 10, this is also not clear cut, as requiring parentheses makes it is a consistency thing that says call a function, or at least it can be, and that is how it is often interpreted by interpreted by those used to it. Yeah, and unfortunately these ones have no articles linked to them. Ironically, the ones that I have questions about are the ones that largely don't have any articles in them. But okay. Let's go into this article first. This is by someone else. 100-Year Mistakes by Eric Lippert. Lippert. It's his blog. This is their blog here. The last post was in January, so not too bad. Like still active. Right. Let's have a read of this because I'm curious what mistakes exist. It'd be some good like context going forward. God damn it! I have to zoom in so much. My manager and I got off on a tangent in our most recent one-on-one on the subject of the durability of design mistakes in programming languages. What do you mean the durability? A particular favorite of mine is the worst. Oh wait, is this like how long they've survived? A particular favorite of mine is the worst of the operator precedence problems of C. I don't know. Yeah, what is that? The story of how it came about is an object lesson in how. I think you can say in how like a model lesson in object lessons. Really, in how sometimes gradual evolution produces weird results. Since he was not conversant with all the details, I thought I might write it up and share the story today. First off, what is the precedence of operators in C? It's not just like, I don't know. For our purposes today, we'll consider just the operators and, bit and equals, which I've listed in order of increasing precedence. So equals has the highest precedence. Well, that's a problem, right? Consider. Okay. So here, this actually, y equals z compiles first, right? Remember that before 1999, C had no Boolean type, and the result of a comparison is either 0 for false or 1 for true. I didn't know that. I didn't know that. Is T supposed to equal R or S? Now, I would suppose that, also from my experience, that T is S. But like reasonably, I would expect it to be R. Many people are surprised to find out that T is equal to S, yeah, because equals is higher precedence than AND. The comparison result is an input to the AND rather than the AND result. Yeah. What is the origin of this egregious error that has tripped up countless C programmers? Okay. There was no double AND operator in C back in the day. I did not know that. Right, let me go ahead and make an article from this. Well, actually, no, I'll do it later. I did not know that. But it does explain. Yeah. Right. But it's not lazy, right? Oh, no. Okay, so AND was context sensitive. I see. So you have AND, the lazy form, and double AND is the lazy form, single AND is the non-lazy form. Yeah, I do know that. I'm aware of that. Okay, so the reason that Dennis Ritchie didn't change it is because it would break existing code. Several hundred kilobytes of existing C code. Several hundred kilobytes. Is that a lot? Is that a lot? I don't know. You might say just search for the source code for that pattern, but this was 2 years before grep was invented. So Ritchie maintained backwards compatibility forever and made the president's order this. Okay, I see. Or maybe it's making a point that there really wasn't much and that this wouldn't have been so disastrous. Because, like, again, like, yeah, like, it really is a handful of people, right? It gets worse. C++ Java, blah, 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 and who knows how many other languages largely could copy the operating precedence rules of C. I mean, C++ obviously had to. Like, there's no question. Unless they replaced the double and with an and keyword instead. But that was already used as well as an alias for double and. So, like, either way, they couldn't even do that, to be fair. So, C++ definitely gets off the hook here for it. But, like, Java, JavaScript, C#, PHP, no, sir. So C++ didn't have a choice, unlike the other languages. Swift, Go, Ruby, and Python get it right. Nice. Fortunately, it is mitigated somewhat in languages that impose type system constraints. Yeah, in C# it's an error to treat an int as a bool, but still it is vexing to require parentheses where they ought not to be necessary. Were there justice in the world? This vexes me. The moral of the story is, the best time to make a breaking change that involves updating existing code is now. Because the bad designs that result from maintaining backwards compat unnecessarily can have repercussions for decades, and the amount of code to update is only going to get larger. It was a mistake to not take the breaking change when there were only a few tens of thousands of lines of C code in the world to update. Okay, it's 50 years since this mistake was made, and since it had to come embedded in popular successor languages, we'll be dealing with its repercussions for 50 more at least. My head is actually going. Yo, where's my water? I mean, yeah, the best time is always now, but like it's a question of like, even so, there's the question of whether you should break code at all. A language like C++ certainly doesn't want to. Yeah. The bigger issue, honestly, like, no. I think the moral highlighted here is wrong. Is misguided. The real moral is that we should not so carelessly copy features and ways of doing things from our predecessors without giving them proper thought. Well, yeah, so mindlessly. If any of these languages besides C++ simply stopped for a second and decided to I decided to change the status quo that's C set, this would not be, well, yeah, this article wouldn't exist, wouldn't even exist. So let me turn this into a note. Oh, sorry, I didn't fucking write that. We should not so carelessly. We shouldn't so carelessly copy features and ways of doing things from predecessors without proper thought. Otherwise, we end up propagating bad decisions into the future. Where they have no good reason to, to continue plaguing us. Systems, decision making, not just programming languages, but I will also put it under programming. Actually, no, I won't. Yeah, so think before do not copy ideas mindlessly. Apologies. And I'll make another note here. The operator, well, C's operator was added later into its development as and was used to instead be context dependent, and sometimes in that it would sometimes lazily evaluate and sometimes not, and was added, and took the role as the lazy and. I imagine the same is true of or and or. I'm aware I use the same link and I could like turn that into a post now, but I don't want to. It's not worth it. And C used to only have one AND operator. Can I use double quotes? I can. This is C, and by extension C++, but not really. Design, maybe? I think so. Okay. Oh, let's look at these comments. Now, funnily enough, actually, there's an argument for not having precedence at all. As I said before, like Clang Tidy will require that you put parentheses anyway, just to make things easier to read. Like, yes, it's cumbersome, but like at the same time, it's just it makes things more thoughtless, and I mean, like, thoughtless in a good way, because you don't have to like look at it and go, okay, yeah, so times has higher precedence than plus, and like plus has higher precedence than equals. Like, no, like you just write them all in parentheses, and Bob's your uncle. Okay, so let's have a look at some of these then. So first of all, properties. What is that about? Pick 2. Fields and methods and properties. Okay, I'll pick 2, fields and properties. TLDR, properties are a hack employed to retrofit nice syntax into languages that are already shipped with fields and methods. Instead, design the language to deliver the same or more benefits with fields. What? But the more I zoom in, the more it like changes. It turns bold at some point for some reason. Well, what's like the most I can zoom in? This much, I guess. Okay. So why do they exist? The core feature of properties, in rough terms, is that unlike getters and setters, property invocations look like field access, but retain the possibility to add logic that is executed on access at a later date. Yeah. Which are... Yeah, so this is something that I've been thinking about ever since I first used them in C#. And also just in general, like, it's very interesting. Examples of languages with properties: C# popularized them in version 1 and extended their feature set in subsequent versions. Yeah, I'm aware of this because I've been using C#, I think 4.0 for a long time, and so haven't had a chance to use much of the 7.0 features, just because the game I'm modding in Unity, a decompilation wasn't made in like 2013, so it's quite old. This means that instead of get first name, users can just write dot first name. Yeah, I'm not a fan of this. It's very dodgy, and like blurs the lines between like actual fields and fake fields, I guess. In C# this is not perfect. Changing a field to a property is source compatible, but not binary compatible. And changing a getter setter pair to a property is neither. Yeah, there is a pattern in Java where you do just write a bunch of manual getters and setters for everything. Like that is the expectation, is that if you have variables that can be publicly accessed and also set, then you write a getter and a setter. Or if they can't be publicly set, then but let me rephrase. In Java, it is a common pattern to make all your variables private, but then use public getters to access them, and then if you want to also have them be mutatable, then you add a set method. But at no point are you supposed, conventionally, should you have a public variable, because then if you want to change the variable name or change how it works behind the scenes, you have an issue where you break your existing code in your API. So having just relying solely then on getters and setters for interfacing with a class is safe. It's future proof, but it's also really verbose. And then C# having getters and setters like this can be used one such way to mitigate it. Now here's this pick 2, which is interesting, as opposed to saying don't have properties. Honestly, if I were making a language right now, I lean towards methods and properties without fields. Anyway, Kotlin. Kotlin also has made this more simple. Fields versus properties versus methods. They've been copied from C# poorly, and it's a large regression from Scala, although Scala is quite different. Swift has store properties versus computed properties and methods, which is slightly better syntax than C#, but it makes it a large language with high complexity. I haven't used Swift. Swift is a language I want to use. I hope we get to use it. I think we do get to use it next year for our app development module in my university, which is by far the module I'm looking most forward to, because I'll be able to use Swift on the MacBooks, well, the iMacs. But that's only if I get into the course, because it has the module, because it has limited spaces. Stored properties are constant and variable. Computed properties calculate. So stored is like first value and length, right? Yeah, so same as normal variables then. Whereas okay, lazily stored. And then computed. With get and set, I guess. Okay. Why is it better syntax in C#? I don't understand. The problem with properties. Also, this post was in 2022, so it's possible that C# has added some more sugar, which might make it match Swift. But I don't know. Conceptually, it's a bit icky that languages feature 3 constructs to define members that fundamentally only express 2 categories: members that store fields and members that compute methods. Okay, all 3 compete for the same syntactic sweet spot and pollute the mental model, as they can be thin wrappers around their storage, auto-implemented properties in C#, store properties in Swift, or contain complex custom logic. Okay, which desirable characteristics should fields, whatever language provide? Nice syntax at use and declaration site. So nice syntax at the use site and declaration site. Okay, evolving access should be source and binary compatible. Okay. Users should be able to see whether they are accessing a value directly or whether computation will occur during access. Yes, I agree as well. Also, I do wonder if like a language like C++ had used the properties model for their stuff, could they have saved a lot of the backwards compatibility issues, I wonder? Maybe. I don't know. Yeah, because like, just in general, future-proofing syntax is very interesting. How to deliver these characteristics without needing fields, methods, and properties. So use keyword-based syntax to distinguish between fields and methods. Between fields and methods. Okay, I guess. This means that methods without parameters do not need to require this to distinguish them from fields. So like in C++, for instance, and I guess like Java. Right, okay. No, yeah, I see. Rust very much makes them differentiated. Define that members live in the same namespace. Yeah, so this I still didn't understand. This prohibits a type containing a field and a method with the same name. Yeah, they should do. Again, like what languages don't do this? Implements late enough binding of member invocations. This avoids encoding field method invocation differences into call sites. Okay. And expose the difference between a field and a method invocation through the use of colors in the IDE. Now that's harder because that relies on you having an IDE. Yeah. This is an interesting topic. Since IDEs can do a lot for us, should programming languages be designed with specific IDE, well, with particular IDE features in mind? Or should we still account for IDE less programming. Like, you can set up like an LSP, like with NeoVim and whatnot. I don't know. I mean, syntax highlighting is obviously pretty basic. Like, it doesn't take much to get that working. With modern development environments like NeoVim, you can get, well, I mean, I say easily, not really, but like, you can get colors set up on NeoVim. But yeah, NeoVim comes with its own tree-setter parser, right? So that's a bit easier. With like normal Vim, it's harder. But yeah, colors, I don't know. Color, in particular, colors is an interesting thing to focus on. Historically, we've used casing. We've mixed casing to help out. Colors come with other issues like colorblindness, but whatever. To be fair though, if you're using colors in this particular scenario, you don't need the colors, right? Like, the colors aren't necessary. It's more that they just help you quickly parse it visually. Like in in functional programming languages, you know, like the line between a function and a variable are so blurred anyway, because variables don't exist. Like, variables are constants, which might as well be a function that returns a constant. Anyway, how to replace property getters with fields and methods. Consider a class definition with one field, name, and two methods, first name and last name. Now, one idea I actually had back in the day, like quite recently, was have get and set as built-in constructs in the language, like built-in grammar, where if you have get underscore and then a variable name, it gets it. If you have set underscore and the variable name, it sets it. And then you can have a variable and then define a custom getter and setter if you need to. But like, either way, it's just clear that you are getting and setting. But that's not a great idea. It's just an idea. Better would probably just be to only have properties at that point. But anyway. So we have a class person with two functions, first name and last name. And there's no parentheses. Okay. Interesting. As a mental model, a desugared encoding of name could look like this. So the fields go here. That is interesting. But it's unclear if you are calling a function or a thing. And even if you were to do like syntax highlighting, I don't know. I don't love this because like it's kind of like hiding a function invocation as a variable access. Like, relying on colors to do it doesn't really change the fact that you're still kind of abusing, well, like blurring the line between a function and a variable, even though they are quite different in a language that supports mutation. Okay. So that's for getters, right? How about setters then? Mutability is on its way out. Interesting. I'm guessing this would work with like plus equals too. Okay, so basically this is implicit, and you can redefine it, override it, by defining a set rating function. Which is what I was getting at with the get and set built-in things. Except you still call it to like get and set. Hello? Home? My home? Yeah? No? Huh? I'm not coming down. Don't want to. Don't care. I'm not freeloading. Don't care, I'm not freeloading. Bye. Okay, open this now. No. We're so sunny. Define a function check rating. Yeah, this is getting really messy. And what if it fails on runtime? I mean, sorry. So in a language with this new mutation, then you don't have variables anyway. So like it really is just a non-issue. But then like this way of defining setters is really messy anyway. As well. If anything, you should create a new type at that point. Or like build like the check into the function call if it's specifically just for that function call. Like just something, I don't know. This isn't tickling my fancy. What's the code then? Concluding event in music. Interesting. I don't really know. This didn't really answer my question of like, but like at least like this doesn't seem like a suitable solution to me. I mean, first of all, the whole check thing is just a bit kooky, but like that can be merged here anyway. That's not a particular issue. But like set rating being like built in just for this, so like it will auto generate based on the name here, which also means like the casing gets messed up, and like the fact that like it relies on like LSP to highlight the colors. I'm not a fan of that, but okay, it is an idea. But yeah, I don't know. Okay, let's next one. Let's have a look at this. Stop using this for generics. What? So now I can zoom in without it going bold. No. Okay. TLDR, use this instead of this for generics. It will save you a lot of avoidable trouble down the road. Okay. I'm gonna get some water. I have an idea, which is design a programming language, but build it from the ground up. Sorry, test it from the ground up. So like start with variables or whatever, but even then, like you really need like I'm just thinking, if you want to make a really good programming language, how do you start? Like, what's the best approach? Because like making features in isolation is going to give you a fragmented language that isn't consistent. That is probably not consistent with itself, because you have kind of just thrown together features that may not be connected as well. If you start like from a ground up approach where you just like say, okay, first I'm gonna do variables and design a syntax, then I'm gonna do this and then like, you know, like go feature by feature and add it to the language, and then like have each new feature match the old ones, then that creates an issue still, because it's like, what if down the road you realize, oh, this feature actually doesn't work with this at all, and I should remove that feature. But then it's like, well, I've already also then made the other ones reliant on that feature, so now like I kind of start from scratch again, which maybe isn't an issue, like starting from scratch, but like it is time. It takes time, and maybe there's a more efficient way to do it. Plus, you make assumptions like, I want variables first as like a first feature. How do you know that feature is even good in the first place? Like, do you want variables or do you just want constants, you know? So I don't know. But hopefully an answer will come to me as I keep reading this kind of stuff. TLDR, yeah, okay, just show that. So first of all, this is hard to read for humans. I'll call these angular brackets. Angular brackets are hard to read for humans. This and this are left angular, right angular are already used as a comparison in Bishop operators, which as binary operators conform to a completely different grammatical structure compared to their use as brackets. Yeah. This is often in combination with other design mistakes, like the use of both this and this for function calls, or literal syntax to construct lists, sets, and maps, leads to confusing and inconsistent use of brackets in many languages. Yep. Yep. The thing is, right, like the angular brackets are just so useful because they are brackets. Like, yes, they can be confused with greater than and less than, but it's just the fact that they can be used to enclose something. You know, like, it makes them quite useful if you're designing a language that needs at least 4 different types of brackets, right? And, like, it isn't that hard to parse anyway, I don't think. Like, visually, I've never had an issue where it's like, is this greater than or less than? So, like, I feel like that's a compromise to have some symbol duplication specifically for this particular scenario. But maybe you'll find that you don't need 4 pairs of brackets, in which case, great. So that's definitely one thing. I personally have never found this to be confusing to parse visually when coding in C++. When working with C++. This often in combination with other language, with other design mistakes. Yeah, just read that. On top of that, imagine a programming font that in which the height of parentheses, curly braces, or square brackets were capped to the height of a lowercase letter. Okay, this is ridiculous, but exactly what happens with the abuse of the I see. So it's arguing that because the angular brackets are not tall enough, they shouldn't be used as brackets. I'm inclined to disagree here. I don't think it matters. Yeah. I'm trying to think like what other things could be used as brackets as well. They're also like diaphragms or whatever they're called. Like, there are combinations of symbols that you could use, like parentheses with a star for comments in OCaml. Like, that is a form of, like, you know, enclosure. But it uses 2 symbols together. So this is hard to parse for compilers. Many languages that were created without generics in mind had trouble adding generics later on, as old pairs of brackets were already put to use. This, using binary operators for comparisons of bit shifts, were usually the only symbols left in the grammar that are practical to overload with a new meaning. That's pretty much the only reason why that started to be used as generics. Yep, in C++. Yeah. Unfortunately, using this for generics caused parsing problems in every language that tried to use them for this purpose. Why does Java use it, bro? Footnotes. Bro, I really don't like footnotes, because like you have to go to the bottom of the page. It'd be cooler if you could see them on a hover. Parsing ambiguity, type argument versus less than. Okay, so it is. So I guess it is an issue then. Java approaches issues by making the syntax less consistent. Less consistent? Before function return types, but after class names, and limiting where generics can be used. What do you mean less consistent? For instance, not with statically imported methods. The syntax inconsistency is due to the difficulty a compiler would have to tell whether some token stream of instance.foo is the left side of a comparison or the start of a generic type argument with a method call. So you must use colon. Rust also does that. Oh, this is Rust, okay. C# and Kotlin try to retain... Hello? You're here? Speak louder, please. Okay. C# Kotlin tries to retain a more consistent syntax by introducing unlimited look-ahead. Their parsers keep reading input after the thing until a decision can be made. Damn. That's slow though, right? Surely. Why does Kotlin even use it? Like, okay, C++ suffers from a plethora. To be fair, Kotlin does have the issue where although it doesn't have to share Java's downfalls, it's like the familiarity argument for Kotlin is more important because it wants Java programmers to move on to Kotlin, so familiar syntax matters. But even then, like, surely Kotlin programmers could get used to using a different Angular thing. C++ suffers from a plethora of these related issues. The only issue addressed by the C++ committee after decades was the requirement to add spaces to nested closing generics to allow the compiler to distinguish between the right shift operator and the end of a nested generic type definition. Huh? Do you need to? Here. Okay. All of the issues appear to be unfixable. Yikes. Rust is forced to use a hideous superfish operator, so it does. So I was wondering why it uses it, and now I know. Which to distinguish between the left side of a comparison and the start of a generic type, introducing syntactic inconsistency between generics in a type context and generics in a term context. Why does it do this? What? Dude, Rust is so weird. Rust could have fixed so many things in C++, and it's still, like, syntax-wise, and it still just didn't. Like, I don't understand. Rust, the reason Rust has the turbofish operator, boom boom, is to differentiate, is to make parsing angular brackets for generics easier. Well, more feasible. One has to wonder why they didn't just use different brackets altogether. Rust and programming design. Rust's turbofish operator makes parsing angular brackets easier, simpler. Okay, a better design. Instead of repeating the mistake of the past, imagine each bracket has a clearly defined use. So these include the type parameters, this groups expressions, or parameter lists of tuples. Yeah, I'm not a fan of that, by the way. And then angular brackets, sequences, statements, or definitions. Sorry, curly braces. I actually would advocate for using curly braces for grouping expressions in a language where, yeah, basically what Gleam does, I think. If it was Gleam, I can't actually remember now. It might have been Gleam. Angular brackets is only used as a comparison operator and not misused as a makeshift bracket. Okay. So this is an array defines an array. Array 1, 2, 3, set ABC. Sure. Okay. An array indexing in favor of standard function call syntax. So get 0, set 0, 23, put 42. Yeah, I do have mixed feelings on this, to be fair. But I understand, of course. A small amount of syntax sugar can be considered, leading to the following code. Sum at 0, array 0 equals 23.42. This... Okay, look. I wouldn't mind this if it didn't look like a function call. That's my issue. Thankfully, the number of languages using this for generics seems to increase lately, with Scala, Python, and Nim joining Eiffel, which was pretty much the sole use of this for decades. What's Eiffel? Okay. It remains to be seen whether this turns into title change, similar to the widespread adoption of indent type over type indent in modern languages. Go and Carbon are indeed adopting it. Cool. Python and Scala demonstrate that this approach works incredibly well. But they still use braces in Python, like brackets. Okay. Okay. Where's this highlighted? Oh, right, because I went back to it. I don't like how this can easily be confused with a function call. Maybe a language just shouldn't have functions. Maybe that's the solution. No functions, just classes. And a function is a class, and you can trigger code via the constructor. That's it. Will that work? Did that work? No, it wouldn't work because like this has to return into like let's say this returns an integer. That doesn't make sense. Anyway, and then this is the same article. Okay. Type annotations. What's the max zoom here? Is it 50? Yeah. Use indent type, not type indent. Ident. So, what is ident? Oh, okay. Identifier. In excessive languages, developers generally need to use fewer temporary variables. This means that in a typical piece of code, there are fewer names defined, but those names can carry higher importance. This syntax lets developers focus on the name by placing it ahead of its type annotation. This means that the vertical offset of name stays consistent regardless of a type's annotation's presence or absence. Oh, I see. So the name is easy to find. Yeah. No, yeah, it's true. It's one reason I pointed this out when I was. Did I? I might have pointed this out when I was refactoring my C++ code, my functions to use trailing return types. It just made it easier to find the names of the function. So, because like the name is like the name's there, easy, and the type is after the colon, also easy. So let me actually add this to my notes. So that's quite. That's a very good point. One reason that name type syntax is superior to type name syntax is that it makes the name easier to find, in a declaration, as well as while putting the type, putting the type in a more predictable while also having the type fairly easy to locate. So like let x equal, well, do some examples. So let name string equal Kojo, let x u32 equal 5 4, let's pi f64 equal 3.141592 let's say. The names in the variable names in the above example are all easy to locate as they start on the same vertical line. Then to find the type, you can quickly scan for the boom, for the colon, and thus find the type afterwards. Yes, you can also use the empty space, but there are spaces all over code, yet only one colon for a language like Rust, for a language of this syntax. Right? Yeah. The variable name is arguably more important than the type for someone reading code. The type is more the compiler's concern. So it makes sense to prioritize it, the name, as the easier thing to find. Yeah. Now for us specifically as well, the mute keyword kind of fucks this up. Yeah. So maybe it's something like, I don't know. like this, or like var. It's an idea. Sources. A good reminder that sources is not like a factual source, but more like the source of inspiration. So really, I could call this inspiration. In fact, I think I will call it inspiration, but I'll do that like blanket later. Untitled, yeah, we'll call this name type. I can't use colon. Fuck. Putting the name first in a declaration is easier, makes for easier reading. Input for output. The int syntax naturally leads to a method syntax where the input parameters and are defined before the output result type, which in turn leads to more consistency with lambda syntax, whose inputs are also defined before its output. Yeah. Sure. I mean, the variable name isn't really an input per se, but having the result type afterwards, I mean, no, that's kind of just arbitrary. It's only like this for lambda syntax because of how it parses. Obviously, like C++ doesn't have to do that, or like C rather. Like you don't have to have a trailing return type, so that's really arbitrary. So I'm not sure this is really an actual point. But you know, if you are using trailing return types, then it makes sense just for consistency's sake. Consistency between definition and usage. The way a class or method is defined should mirror the way it can be used. This one is also kind of arbitrary. I don't understand. Like for Rust, let x equals 3. Like, you don't use the, like, let x of type u32 equals 3. Like, that doesn't really mirror the way you'd use the variable. So this is also a non-thing, unless I misunderstand. But this point in general, the way it's defined should mirror the way it can be used. That is interesting, and I honestly almost disagree with that philosophy in general. But hey, definition before usage. A generic type parameter should be declared before it is used. Otherwise, it is hard to tell to what a type argument refers to. What? Okay, as languages have explored various designs, we can check whether they satisfy the 3 properties mentioned above. Java has this. C# is this. This is Java? It's weird. Colon is this. Ceylon is this. And the core language is this. I don't understand. Input before output. Okay. What is Ceylon? Definition, usage, consistency. Definition / usage consistency. Yeah, because that's how you use it. You don't put it before. But again, like I'm not sure that's really an issue. It's just a bit bizarre that it's before. Like I don't understand why it is before in this case. Like how would you read this? Like if I read like this, it's like a function called ID, which is takes the type parameter t, and then this returns t. Right, whereas this is like a function with a type parameter t called ID, like definition before usage. Oh, for the return type, I see. Again, that's why you have trailing return type. Yeah, which Kotlin does do correctly. It's just kind of goofy having it before. I don't. Okay, what's his point? I don't understand what his point is. Definition before usage. Obviously, that makes sense for trailing return types, but I don't understand what it doesn't make sense for this. Other than just trailing return types, but okay. Okay, sure. Good. I got a good note. I got a note out of that. And having so this one I already read. I took no notes in it because again it was pretty much the exact same as what I was already thinking. Quite coincidentally. Yeah. But I'll have a quick look at this again. Ooh. Okay, this one I actually missed. Ternary expressions and if statements can be fully subsumed by if expressions. So, which means you don't have if statements and you don't have, well, obviously not ternary. You just have if expressions. This one's interesting because it's like what, how? Because if that's not true, because if expressions have to be exhaustive. But like what if I just want to do like an if, like else nothing, like like if this return this, else do nothing. I don't know. Switch has a fixed part whose value is compared using an equality relation. Like, sorry, let me just elaborate. An if expression returns a value. If you want to do the equivalent of doing nothing in an if expression, you would need to return like a none in like a maybe type. Switch is a fixed part whose value is compared using an equality relation a set of branch-specific values. If supports arbitrary conditions but allows more than two branches only by chaining if to an else. Splitting conditions into a shared common part and individual conditions conflicts with mandatory parentheses around conditions. Yeah, so remove those. To ensure unambiguous parsing, the place of this shared part. Okay. I don't know why this is highlighted as like a red. Like these are to return values, right? But this is to call a function. So like there's no else here. Although in this case it's exhaustive on pet. But like what if you want to do non-expression? That one I'm understanding less. So that's my question for this article. Hold on. Okay, I don't know. And modifiers and annotations. If your language has annotations, it doesn't need modifiers. Drop modifiers. Some languages like C, C++, C# and Rust use a name attribute for annotations. Okay, good to know. Because that's what I'm used to. Modifiers such as public, static, or abstract were traditionally built into languages as keywords. They were part of the core language syntax. Yeah. Annotations are usually defined in libraries. Similar to a class or interface, there exists a source file that defines each annotation. Is that true for C++? I don't think so. Like no discard is an annotation, but it's more like a compiler thing as opposed to a it is in the standard, but it's more like a compiler notice, if anything. It's kind of goofy. And for Rust, I'm not so sure. Maybe you like mix and match. Okay. Consider this code example containing a variety of annotations, some of which would have been modifiers in older languages. Open, final, deprecated, inline. Okay, I assume this is the core language as opposed to a mainstream one. Derive, stringable. Final, deprecated, inline. Benefits. Wait, but... Okay, benefits. Increase language hygiene. Let me mute my... Dropping modifiers are only using annotations avoids having two language constructs that serve largely the same purpose. Refining the semantics of language building blocks like type or function definitions. Yeah, so it's true that they serve the same purpose. But, like, again, some are library defined, whereas some are built in. Like, inline is definitely built in. Deprecated is probably built in as well, and final is also built in. In fact, I'm pretty sure all these are built in. I don't know any examples of like library ones though. I'm curious. Like, could you have first class annotations of sorts? This also obviates having to think which behaviors deserve or need to be modifiers and which can exist as an annotation only. Modifiers. And like, what makes a modifier a modifier? Like, is mute a modifier? It is, right? Like, mutable, to make something mutable. My issue with annotations is just the verbosity. Like, at final, but like is above it as opposed to like being in line. Speaking of, improved compatibility through namespacing. As annotations are defined as code in regular source files, they are namespaced. That's good. Yep. But that's if there are library ones. And more accessible documentation. Annotations are defined in source code and live as regular source files of the language. Okay. Paths for language evolution and migration. Annotations are easier to evolve than modifiers. Example, the implementation of private visibility has a bug. Fix it. Then add a default parameter to the annotation, such that developers can opt into the old behavior. For larger changes, it is also possible to leverage the namespace nature of annotations. Yeah. This preserves, yeah, okay. Even if the language compiler runtime makes a distinction between language powered annotations. Yeah, future proofing, okay. Drawbacks. Bootstrapping. The language and the compiler requires more attention. As annotations crucial to language semantics have an immediate effect on the interpretation of source code, such as staticness or the visibility types. Okay, handling annotations as early as possible in the compilation pipeline is important. Introducing a keyword to define annotations, like annotation similar to class for classes or trait, is strongly recommended. Why is that a drawback? Okay, high syntax requirements. Sorry. As a cautionary tale, annotations in Scala were classes that implemented this, forcing the compiler to traverse and resolve the parent types or type definition to determine whether some class was actually an annotation. Okay. Lightweight to use site syntax like @ is required, as even moderate syntax costs like this in Rust may feel too much for its intended use as a replacement for modifier syntax. I'm sorry, I mean, I agree that it'd be cool to unify the syntax, but like I just don't understand, because here we have user-defined annotations and built-in ones. Like I'm pretty sure final would have to be a built-in one, but then like that's kind of confusing. Yeah, I don't know. And I wonder what annotations you would use as well that are user defined. It's not something that I've really come across much. Example: target element type method, retention runtime. Huh? Claude. What's an example of user-defined annotations? In C++, I've never used them. I don't think. Claude Fable 5 is currently unavailable. Is it because of the Mythos stuff as well? Like, type thing. Okay. Yeah, so C++ doesn't have it. Likely and unlikely? Man. Likely and unlikely are very interesting and something I've literally never used. And these are standard, yeah. The real equivalent is macros plus templates. Define serialize, kill me. So what's an example in a language that actually has them? I'm trying to think where I'd use likely and unlikely. I guess like in instances where it's ambiguous what is likely to happen. But I feel like the compiler the compiler and or the runtime could generally do a pretty decent job at that. Maybe not though. I don't know. It's not something I've like ever seen and used by someone else. Interface validate default 0, default 100. What? Okay. I see. And then you use reflection to get it. Get annotation. I just feel like there are other ways to do this than using an attribute or an annotation. Like, how about just making? I mean, first of all, this could be built into the language, like a range annotation, or you could build it into the type system, where you have an int that can range between 1 and 999. Like, that's it. The use of min max seems like an issue. This is like something that can be solved through other means, like a stronger type system that allows narrowing of, that allows ranges, or I can't remember what the other one was. Test is a test is also built in though, no? Or is it like an extension of thingy? I don't know. So give me some examples that are truly irreplaceable. Test? Like, is test not built in to the language as well? JSON property. That's for like macros though, right? Like reflection mostly. Okay, so it's mostly for like reflection, is what I'm thinking. At which point, like private and public and static, these aren't reflection things. Those are like built-in compiler things, whereas these are purely up to whoever made the library. So I would argue against. Yeah, I don't know. I would argue against replacing modifiers with more annotations, because then it's just then it's just confusing, because some are like obviously built in, but then some are completely different, and because they are user defined. Yeah, I'm not a fan of this one. Like public and like yeah, that one I'm less sure about, but okay. And that's it, I think. So let's go back to the index. Easy wins, simplicity matters, mistakes were made. Lots of rustlings, interestingly. These are the essays, right? So We've read this, we've read this, we've read this. Failed attempts. There's more. Kotlin tried apparently and gave up on it, as it couldn't figure out how to recognize annotation usages as early in the compiler pipeline as modifiers previously. Okay, so there was a technical issue. This led to the determination that modifiers had to stay, but annotations will not always be able to emit the prefix, leading to inconsistencies. Is it inconsistent though? I don't understand. So why did Kotlin try to replace modifiers with annotations? Aren't modifiers fundamentally different because they're built in, whereas annotations are user defined for reflection, for doing stuff with reflection? They didn't want to add new keywords for every Java in-shop concern. Yeah, but keywords are reserved and break things. I mean, that's fair. But then use a different syntax, like $sign or something, you know? But like, yeah, I mean, I don't know. Claude might just agree with me no matter what I say, but I really would not. Okay. I don't know what Ceylon is. Try the route in which everything is an annotation but looks like a modifier. Yeah, this made it hard to distinguish between important keywords and less important annotations. Exactly. So I really don't like. It's not a failed attempt. It's more just the idea wasn't good to begin with. Ceylon Lang, which I've never heard of. MIT. Fans of Java. Look at this. Shared native JVM. Shared native JS. That is very interesting. And they call native an annotation, but it's built like a keyword. Which I agree with. Okay. Moving on. Useful syntax sugar. Let's have a look. Get sugar. Let me zoom in here. X or get Y can be written as X, Y, but it treats X as a function, so it's kind of weird and goofy, and I don't like it. Also, what do you mean get Y? Oh, like to get array indexing? Yeah. Yeah, no, I just don't like it. Do they address the fact that that looks like a function? No. Set sugar, same thing. Set ... sugar. Okay, well this one is a getter and setter, right? Okay. Is that it? Okay. Yeah, I've already talked about that one. I don't agree with it. This one should be okay. It's very short, but very simple and good. I think there's no good reason. Familiarity. Why some type names need to start with a lowercase letter. Dude, okay, who actually argues for familiarity? Like, I get you want adoption to be high, but like, if your language is good enough that it, like, people should switch anyway. Sorry, there's a good reason why some type names need to start with a lowercase letter. Int, float, stir, and others with an uppercase letter. Instead, pick one naming rule and stick to it while building your language. Oh, stupid reasons. Familiarity, but types of lowercase names are primitives. Yeah, that argument isn't terrible. I'll say that. But you generally don't want that to be obvious anyway. Like, there's definitely a sentiment for having user-defined types basically just be indistinguishable from normal types, from like the primitive types. So, actually, they aren't lowercase type names, they are keywords for types. What the fuck? I mean, no. Just no. Okay, use consistent keyword length. This is interesting. 6 letters namespacing for declaring and managing namespaces. So module, import, and export. 5 letters for big definitions. Class, value, instead of struct. Ooh. No. Fuck no. Maybe? I mean, I'm guessing that's more just to shorten struct than because value is a better word. This is, but like a value keyword in general is interesting, but like this is, I don't know. I mean, why does your language have structs and classes in the first place? Like, just have one, but okay. Union instead of enum. No. Yes, fine. Trait, alias, mixin. What is a mixin, by the way? Like what actually is a mixin? I never understood. I've only heard of mixins through CSS, which is like probably not the best place to learn about it. What are, please type, what are mixins in programming? Okay, so JSON mixin to JSON, log mixin. Am I stupid, or is this literally... Okay, so it's just inheritance, but but it is inheritance. It's just a different mental model, where inheritance is a, you know, user is a thing. Mixins are like user inherits behavior from this. I don't understand this at all, really. This is really dumb to me. Like, just call this, you know, JSON serializable and loggable, and then inherit those. So user is JSON serializable, JSON is loggable, and then those would be your traits. Okay, I don't understand that. Maybe they have something in mind for mixins though. Type alias is interesting. Although I don't really see the point for aliases, to be fair. Like I don't want my type, you know, like my type person to be of type person with capital P, if person simply contains, or like a better example, right? Like, it's redundant. If I have, if I have a string name, right, of type name with a capital N, because name with a capital N is an alias for type string. Like, what? Why? Like, it's already called name. Like, maybe if you want to change it later, you can. But I still don't think that's really necessary. Yeah, I don't know. 4 letters, case, control flow, case then else, or when then else. Instead of if else, I agree. I think, yeah, that's something I've talked about before. Loop instead of while. I like looping, yeah. But I do like loop while and loop for as combinations of keywords. Skip instead of continue, pretty good. Exit instead of return. Okay, I think skip is better, but not because it's short. Sorry, not because it matches these, but just because it's shorter and it makes sense. Exit, there's no really there, and yeet. Sure. Honestly, sure. But also no. I think making these the same length makes sense, but it doesn't need to be the same as this. Control flow. Like, if statements and loops are a different kind of control flow than like returning, continuing, and throwing. But okay. But I don't like exit. I would change it to something else than exit. Because like you want to return 5, not exit 5. That doesn't make sense. 3 letters. Fun for function, let, and var. That's fair. Although let, var, fun, const. Yeah. Unused alternatives. 6 letters for invasive control flow. Okay, good. They actually acknowledge it. Return and throws. I mean, throws. Your language shouldn't have throwing in the first place. 6 letters and then 2 letters. If, do, or. Yep, I was considered or. The issue with or is that or you want to also reserve for, you know, actual or, like in booleans. So. But yeah, cool idea. I think. Cool consideration. I just realized these are easy wins. This is easy. This is easy. This is less easy. This is not even considering, and this is not. I mean, it's not super easy because there are issues like, what about if else? Like, would you do case else or what? Unit operators. Let's have a look at these. Unit operators are a waste of a language's complexity budget. Replace them with methods. Many languages provide unary prefix operators such as this, 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 this. Oh, right. Plus is useless. Negative and positive. Yeah. I've never used positive as a prefix, but sometimes I just think about it simply for the sake of having things take the same line like space in code. But it is ultimately fairly arbitrary, and you can just put like a space before your number if you really care about that. Except for reasons of tradition and familiarity, their privileged position in many languages is unnecessary. They provide rather limited benefits while adding complexity to the core language. Dropping unary operations altogether. So not replaces this on booleans. This is a terrible idea. This is really bad. By the way, for the familiarity debate, I will add, I agree with it in terms of familiarity with other programming languages. I don't agree with it in terms of familiarity with our general day-to-day. Like, we should use decimal numbers, decimal numbers should be supported in programming languages as opposed to binary, because we are very much familiar with decimal numbers in our day-to-day, right? Like, that is a good reason for familiarity. Even though, like, using, like, say, like, hexadecimal might be more compact and, you know, have better memory layout thoughts and whatnot, and, like, it's easy to see if you are exceeding a variable's limits, because, you know, 0xff is going to fit within two octals or 16 bits, right? 1 byte, let's say. And 0xfff is a limit for 2 bytes. You know, like, that's very clear. But we shouldn't use hexadecimal because we are using decimal anyway. So, like, that kind of thing, you know. Likewise, we are very much used to using negative numbers in our day-to-day. So doing 1.negate is actually stupid as hell. Likewise, not. No. Yeah, I'm gonna say no to this. Like, just have not be a one argument function, such that you call it and it inverts it, like, and, like, it doesn't require parentheses, you know. But, like, some bool.not is just funky as hell. Notch replaces this on integers instead of this. I don't know what to say. But so far, that's all cooking. It moves the negation closer to the thing being negated. If language.users.map... fuck me, I can't read this. If languages.users.map... man, I really don't... _.last name. Contains Smith. What is this? Like, it's just getting the last name field. So it's like shorthand way to do lambda expressions. That's good. Is it good? For, like, access. It's useful. A bit confusing, but it's useful. Well, confusing at first. Contains Smith.not. I mean, I feel like whether or not you agree with this largely depends. I mean, first of all, this is just terrible. We are not doing negatives, but for this one, which is the more reasonable, I don't. I mean, like, dot not should be a function in a way, a function call, so you might even want to use that, but, like, that's another kind of worms. Whether you prefer language.users.map.contain Smith.not Or like if I like, let me read this in English, right? If languages users field mapped to just the last name contains Smith not, then do this else this. That's weird, right? Versus if not languages users maps the last name, fuck me. If not if not languages users mapping just the last name field contains Smith, then do this as this. Like that's not just a familiarity with programming languages. This is English. This reads really weirdly and fits more in like Japanese grammar, if anything. Shout out the Nadeshiko, Japanese programming language, by the way. Because like then you have like nai at the end, right? Janai. Like in English, there is water, there is not water, right? Or in Spanish or in Japanese, mizu ga arimasu, or I don't know, mizu ga aru, and then mizu ga. Okay, better. Mizu. Okay, how about this? It is water versus it is not water. Mizu this, mizu janai this, right? Or okay, if my knowledge and understanding of Japanese grammar is better, but point is, it's at the end, right? But here, it's kind of it's just a bit weird. Yeah, I don't know. This one I'm not a fan of. And like there's really no benefit. Like the benefit, like they said that you get the condition closer to what's being negated. But like the English brain is already pretty damn good at just maintaining that anyway, because of how it's used to storing not before. Like if I say, alright, I don't want you to go to the park and start barking like a dog. Like you've pretty, like that shouldn't be confusing to any English speaker, because you've registered the don't want you to go, right? So you're like, okay, then I won't. Whereas if I said, I want you to go into the park and start barking like a dog, not. It's like, okay, like at that point, it almost seems like you're trying to like psych me out. Like, I want you to go to the park and start barking like a dog, not. Like, okay, no, stop, don't do that, don't do that. That is okay. Like, no. There's a bigger argument, a bigger discussion to be talked about the grammar of programming languages and English grammar, because we use English words in programming, and that is an issue, because it means that we then expect English grammar to also be consistent, to be used, right? With Japanese, like park, I don't want, park I want you to go not. Park I want you to go not. Like the best way to read this from an English perspective would be if, okay, ignoring the other stuff. If languages.users.map.lastname not contains Smith, right? Not contains, and like Haskell literally has the not lm function alongside the lm function, probably for that reason, because it just reads better than not this is an element of this. I mean, it's not that huge difference, but like I see the vision, I see the vision. Okay, this is definitely worth thinking about more. Let me make this a post out of this. A post. A blog. What the fuck? A note out of this. A source note. Appending. Okay. Yeah. One dot negate. Instead of -1 is 100% a no-go. Because then we are, because, yeah. In general, we should try to take advantage of our familiarity with the everyday when designing a programming language, and something like one dot negate is up there with the bad idea of only allowing programmers to type numbers in either numbers in base 2 or base 16. However, boolean.not, my bool.not is a more convincing, is a more reasonable suggestion for replacing not my bool. Really comparing, yeah. More accurately comparing to not my bool. The main issue with .not is how it reads grammatically in English. But this has been an issue, a general issue with conditional statements / expressions in programming forever anyway. E.g., if has actually, it is just not, isn't it? But it's not like putting not before a long Boolean expression is any is grammatical either. E.g., if not foo dot is ready. Would read more naturally if foo is not ready. But but that doesn't mean that such syntax is a good idea. Okay. It's growing on me. The idea is growing on me. Definitely opposed to this, but this is growing on me. The bigger question is how you do not equals. And like it can be a bit more verbose as well for like let's say I have not 5 is 3 versus not 5 is 3, probably the better way to do it, versus 5 is 3 not. If anything, this calls for a new, well, calls for a different type of syntax. For a new syntax which is still for unary operators, but appends them to the end of expressions. Like 5 equals 3 dot not should not be viewed as should not have not be viewed as a property / field, right, of the expression. Instead, something like 5 equals 3 not would be better. Would be better. Would be clear. Would be more differentiating. Okay. It allows the use of more elaborate result types, while the negate operation may always succeed on arbitrary precision numbers. The same operation on the more common fixed size types could benefit from returning an option result to indicate that a negative value may lack a positive counterpart. You can do that anyway. Yeah, you can do that anyway. Right? Or just having not be a function, but just having before. Like this is kind of a non... What's the fallacy called? Where it's like you're kind of just talking about a non-issue that doesn't exist, like making it as if it's an issue. Like that's kind of what's going on here. It is unambiguous. Code mixing unary prefix operators with other operations can be confusing to readers. For instance, whether -1 dot abs if I was to 1 -1, and if the precedence only applies to literals, or also code like let x equals 1. -x dot abs. With methods, the code is unambiguous. x.negate.abs. Yeah, but it's also unambiguous. Although x.negate.abs is less ambiguous than -x.negate, abs, there is, you could also just do -x.abs, or even abs of -x. In fact, you definitely should include parentheses. Yeah, like there is almost no reason why some form of parentheses wouldn't be preferred. Again, it's just weird. If you just like a note, right, for people who write articles, if you're going to make arguments on something, you have to consider the other options and the other sides, or like just the other options. Like, again, like this is kind of creating a false dichotomy. Well, it is creating a false dichotomy, where it's like you either have this or you have this. So like anyone who reads, would of course be like, oh yes, that makes perfect sense. But like, okay, but like it's not a dichotomy. You have these other options too, and for 100%, abs and negative x is the correct thing to do here, and in language that supports that uses functional call syntax like this. But even like in Haskell, right? You would, like, Haskell forces you to put parentheses around your negative numbers. Languages like Haskell even force you to surround negatives with parentheses. But that's not true, because like in Haskell, you don't have to do that if you are simply just defining a variable or a constant, like foo equals -2. I don't think you need parentheses there, and that's fine. This is weird, bro. Appendix, list of languages and their interpretation of -1.abs. It should be -1. It should be -1. If it's not, you have an issue with your language. I'm trying to think, like mathematically speaking, even -5 to the power of 3 is treated as negative times 5 to the power of 3 because how precedence works with powers. So like that's just like one reason why -x.abs being, or like -1.abs being 1 would seem unintuitive to someone who's done maths. These should be the same, right? Ruby has a different, and Scala has a different as well. Yeah, no, they should be the same. C#, -1, -1. Core is 1, so core is really failing in that regard. D, Dart, Phantom, Groovy. What's Kitten? Stack based. Because it's stack based, it gets a pass. JavaScript, Nim, Raku, Ruby. Ruby's fucked. Rust, Scala's also kind of fucked. Smalltalk. Yeah. The Rust community has a smaller discussion about this syntax, this topic. Let's have a look. The is not empty method. Not is empty. No. Literally, what is wrong with not is empty? Like, you want to... No. It just reads badly. But let's keep going. Here's bullet not. Okay, can be a problem. If a developer writes a condition in the form, if actually more than 0, could be helpfully notes that using is empty is clearer and more explicit. The developer doesn't pay enough attention to the example code that Clippy gives, or solely mistypes, and replaces their condition with if vec.isEmpty. Whoops, they've just flipped their conditional. What? the bigger question is why Clippy is even telling you to do this anyway. Clippy shouldn't tell you to use is empty. It should just like it should literally tell you use is not empty. Like not is empty. I don't understand why it's doing that. Now whether this is enough to justify this in a new method, I'm not sure. Hell no. It seems like most of the time it's the opposite of the method I want. So not vec empty is more common than vec is empty. Yep. Not this. Use a not keyword. Not A and B should be not. Well, really, a language should force you, I think, to use parentheses. I'm actually in support of that. But in this case, not should have lower precedence than and. Actually, no, I think not should have high precedence. So not A and B. But again, just use parentheses and then it becomes a non-problem. Pool could add inherent .not method. Vec is empty .not is readable, but reads funny. I think even mathematicians these days will still use parentheses, even in cases where pedmass is a thing that people can utilize, simply because it just makes things easier to read. Bool could add inherit .not method. Vec is empty .not is readable, but reads funny. It reads funny, but you get used to it, right? Vec is empty not, which honestly isn't even that bad, like English-wise. Like I said it's not grammatical, but it kind of is. Like you can say, my vector is empty not. Like maybe it's archaic grammar, but I assume it's still grammatically correct overall. One of the points is very difficult to read. Yeah, like this. Again, this. Alright, Rust stations. Okay. So then we have the binary operators. I'm going to read this quickly because I want to get some dinner before Little closes at 10 p.m. Use methods. Many languages provide binary operators, usually for... Sorry, before I do that, I need to actually write this down. Users are necessary by sock. We got a date. 2025. What's the last time it was dated? 2025 05 21. I use this, right? No, I use. Okay, yeah. Authors is sock. Published. In this case. This should really be accessed, but I'll change it later. Tags, just article, right? Interesting how I don't have article here. Online video, online article. IDs, mirrors, preview. Okay. Okay. Now for this one. Many languages provide binary operators, usually for operations and numbers, as multiplication, bits, and blah blah blah. In general, this language facility has been overused, forcing users to learn and recall precedence and associativity of dozens of operators. Additionally, some popular operators have additional problems. Again, just use parentheses. I feel like that's a really key solution that's not being noted here. The problem with and. Many older languages that were influenced by C also inherited its incorrect operator precedence. Now, newer languages like Go or Swift avoided copying this mistake. Sorry. The problem with this, languages like Java or JavaScript that decided against providing both signed and unsigned number types often offer two operators for shifting bits to the right, one that preserves the assigned bit and one that doesn't. This is also a different issue than what's being presented. The issue here is that operators in general, like it has a general issue with operators that isn't because of binary operators or union operators or whatever. It's because, like, when you say that there's an issue with binary operators, what I think of, there's an issue with having A symbol B, right? Like specifically the position, and that you may instead want to advocate for symbol AB, right? the problem here is it's not the ordering or the precedence. It's the fact that the issue being highlighted here. They're saying that the issue is that their operators exist full stop. Like in math, we had plus, we have minus, right? But like, would you remove that? Like Haskell has like it's forward equal sign for like the bind operator. Like that's definitely a good argument, but that's a different. I feel like that's a different topic than what this article has set off to talk about, which is weird because it's so short anyway. The problem with modulo in most languages, it permits a remainder operation, not a modulo. Remainder and modulo, yeah. Yeah. There are 5 possible implementations: floored, ceiling, truncated, Euclidean, and rounded division. Damn. And then sensible source operators. Okay, so they are advocating for just these operators: equals for assignments, or an and. I don't think you need that. I mean, or and and aren't even like intuitive anyway. Like to a non-programmer, like you would expect to just type it out and an or. Equals, not equals, less than equals, more equals, triple equals, not equals. There's stuff to say about not equals and double equals, as well as the triple and whatever. Plus, minus, times and divide. Plus, minus, times and divide. I mean, even divide like could be an error if you give it a 0 as a second argument, right? So like that's already unsafe. Plus and minus are fine, but like no, because like plus could overflow, so that's also an issue. Minus could underflow if I do like 3 minus 5, like the has to return an unsigned, right? Or if I do negative whatever minus a massive number, then like that can also overflow, so that's also unsafe. And times, because like all of these are unsafe anyway. But like, what you want to do? Like replace them with keywords or like function names? I wish this article elaborated more on what could be done alternatively. Yeah. Let me finish by reading this one, because just like to finish the group. Optimize for the common case, not the exotic ones. The argument is not that break and continue in loops are unuseful, convenient, and the best option. Is that they are optimizing for an infrequent special case. So consider a code base has 1,000 loops. 900 loops aren't using break and continue. Why is it bad that they make the 1.5% of the loops more convenient? Also, this is assuming that, 10% use break and continue, which is kind of arbitrary. Like you kind of making up numbers here. That's not necessarily going to be the case at all. In fact, break can be used quite frequently, if anything. While we're seeing the general case. What's the detriment? The loss of the ability to... Okay, so like this is what actually matters. The loss of the ability to read the head of the loop and know what's going on. Yes. This I agree with 100%. Like while true, I always hate using a while true loop or just a loop in Rust, because it's like I'm trying to think when I need to use it. I use it to avoid using flags, right? And it's just like it's annoying that I can't know when it expires. This inability is so ingrained in people that they cannot fathom the mental load that gets removed when they do not have to keep this loop, make it a break and continue in the back of their head. Like continue equal true, while continue equals should break dot not. Oh, for fuck's sake. Should break dot not. How about an unt thing that says should break dot, or like should breakant? I think that could actually be pretty good. Conclusion: dropping break and continue removes mental load from 98% of them that use them. Is a good trade-off. I agree. I agree. It's cumbersome, but I agree. This argument is a bit silly, but I agree with this. The main like the reason I agree is because of this, with the condition just being unambiguous. So yeah. Mind you, you could go the other way, and say the condition gets put wherever it needs to be put instead, and no condition goes here. You only put the conditions down here somewhere, and then you have break and continue syntax. That's an idea as well. Which would make reading a lot harder, so probably worse. Okay, I'm gonna end this recording here, but I will read more of this later. I just need to go sort out dinner before Little closes. So yeah, good read so far, very interesting. So I just want to make it clear, when I read stuff like this, and obviously like I criticize it, it's not to like I'm not being mean, or like not mean, it's not to be hateful. It's to just say I've considered this and I disagree because of this, and I don't like this, and because I don't like it, I'm gonna express my disgust and my dislike for it, on the idea, okay, not the person who wrote it, because I feel like as I keep reviewing different things, like part of me feels bad about criticizing, but I shouldn't, because again I'm criticizing the idea in hopes that we can come to better solutions. Yeah. So I just wanted to address that, because I don't know, like it's felt kind of weird lately. I mean, I say lately, for a long time, but like it always feels weird to give feedback to something. It's a lot easier online when you're not like talking face to face with the person, but even then, like, because I'm against cyberbullying, I try to imagine as if I were to talk to the person, and like that's when it feels weird. So maybe I can do something like with my cadence even to make it feel that way, less that way. And like regardless of what you, the viewer, thinks, it just I'm just pointing out that it makes me feel weird. So yeah, I'll sort something out like that. Anyway, to be continued.